right, we are going to be working with radicals and determining that they do everything just like we did with any other variable. They have to look the same. So you could always add things like x and x. They are like terms. X squared and x squared are like terms, but x plus x squared are not like terms. So and the same thing holds with radicals. If the radical looks the same, so you have the square root of x and the square root of x, you can add them together, okay? So you have 4 square roots of x plus the square root of x. And remember, if there is no number in front, it's an implied 1. So 4 plus 1 is 5 square roots of x, okay? And so you're going to have several of these type problems, and you've got to just combine like terms. You can add, you can subtract. There should be no issue with that. You might move on to something like this. Anytime you have numbers, you got to ask yourself, can I simplify that? Can I take the square root of 16? And the answer is yes. And that would give me 2 times 4 minus 3. Can I take the square root of 5? And the answer is no. That's in simplified form. Okay? So then I would have 8 minus 3 plus the square root of 5. 8 and 3 are like terms, so 8 minus 3 is 5. And then I can't combine anything with that square root. All right, now I might get something that looks like this. They all got the radical of 5. So obviously they must be all the same, but they're not. So pay very close attention to this. This is the cubed root of 5, this is the square root of 5, and this is the square root. Square roots go with square roots, cubed roots go with cubed roots. So only these two are like terms. So what is 7 minus 9? And that gives me a minus 2 square roots of 5. And then I also have the 5 cubed roots of 5. Okay, so when combining like terms, they have to be identical, completely the same, otherwise they are not. You might get something like this. Okay, and so what you have to do with a problem like this is you've got to simplify 45. Can anything come out? Okay, and again, I like doing the factor tree. Okay, so I know 5 times 9. 5 is prime, and then I have 3 and 3. So that's the square root of 3 times 3 times 5. What about 20? I got 5 and 4. 5 is prime. I'm going to keep going. That's 2 and 2. All right. So minus the square root of 2 times 2 times 5. Okay. And the radical here, it says what kind? This is a square root. Square root means 2. So I'm looking for twins. So that's a set of twins, and that's a set of twins. All right. So that's going to come out giving me 3 square roots of 5 minus, and then the 2 can come out 2 square roots of 5. 3 minus 2 is 1, or the square root of 5. So is this the same as this? And the answer is yes. I didn't test this out in Math Excel. It may tell you no. You may have to do only this answer. But note, I would completely accept this 100% as an answer too if you gave it to me on a test. What about this? Okay. Again, it's similar to the last problem, except I've got 3 numbers I've got to work with. So I got 75. Well, I know it's 25 and 3. And I can break 25 down to 5 and 5. Okay, so now I have 2 times 3 times 5 times 5. And then I got 50, which is 2 and 25. 5 and 5. So then I have minus 2 times 2 times 5 times 5 plus 27. Factor tree that out. That's 3 and 9. And then I have 3 and 3. 3 times 3 times 3. Okay? These are all square roots, so I'm looking for twins, twins, twins. All right, so that's 2. And then when the 5 comes out, it gets multiplied by that 2, and the 3 gets left inside. Then I have minus 2 times 5 times the square root of 2 plus, and then I have that 3 that comes out times this with a 3 left inside. So 2 times 5 is 10 square roots of 3 minus 10 square roots of 2 plus 3 square roots of 3. Okay, and again, our radicals got to look exactly the same. So they're all square roots, but then the numbers or the variables inside have to be exactly the same. So only these two are like terms. So I have 10 plus 3, giving me 13 square roots of 3 minus 10 square roots of 2. The other thing we can do is multiply. Okay, but before I multiply, I'm going to take my 35 and I'm going to break it down to the prime components. What times what is 35? It's 5 and 7. So effectively, I have square root of 5 times 5 and 7. 5 times 7 plus the square root of 5. Okay, so when I distribute, it would go inside. And I can put it directly in. I can do 5 times 35, which we have done in the past, but this time I want to leave them in their prime components because it's easier to factor. Okay, so if I have the square root of 5 times the square root of 5, which would give me the square root of 25, but it's also just as easy to see 5 times 5. Okay, so that's a twin. That's a twin. So that comes out 5 square roots of 7 plus 5. Okay, you cannot leave it as something like, 15. The square root of 85 plus the square root of 25. You always have to simplify that radical. Just like a fraction, you always have to simplify. But the last thing we can do, so not only can we do one distribution, we can also FOIL. So here I would have 7 times 9, which is 63. And the square root of x times square root of x gives me x. Then I have 7 square roots of x times negative 8, which gives me minus 56 square roots of x. Then my insides give me 1 times 9 square roots of x. So that's plus 9 square roots of x. And then 1 times negative 8, which gives me minus 8. Okay, my like terms are negative 56 and 9. So I have 63x minus 47 square roots of x minus 8. Okay, sometimes these numbers, like this would be a 63 minus an 8, and then you would combine those like terms. But unless everything's the same, just make sure you check and go slowly. Okay, so your rules of FOILing, factoring, multiplying, they all stay the same. You're just using radicals now. All right, ask me any questions you have by email or in class.